Hello students. On the MyMidi page I have placed a review guide for Newton's law of motion, and this is a short video that will help to explain. So in the first part we talk about Newton's first law of motion. This is also called the law of inertia. It states that an object at rest will remain at rest, an object in motion will remain in motion with the same velocity and direction unless acted upon by an unbalanced force. So it's important to realize that a force is a push or a pull. Now, objects will only move if they are stationary, or will become stationary if they are moving, if they are subject to an unbalanced force. What does that mean? If a force is unbalanced, it means that the net force is not zero. If all the forces on an object are balanced, then the object will not move and the net force is zero. But if the forces are not balanced, then there's going to be a force in one direction or another, and this is going to cause motion. Let's have a look at the example of the two footballers. The guy in the red shorts is going to kick the ball with a force of 75 newtons. Coming from the opposite direction, there's the blue shorts guy kicking the ball with a force of 125 newtons. So the net force on the ball is going to be 50 newtons. You're going to simply subtract those, which means that the ball is going to move this direction. You can see the ball goes from stationary to moving because it is subject to a net force. If you look at the example down below, this one right here, two people are pushing, or one is pushing rather, and the other is pulling on this object. So the combined force is 300 newtons and the object is going to move along that way. The most important thing to remember is that unbalanced forces cause motion. Friction is a force. It's a force that opposes motion. So you have to take this into account. For the quiz today, you do not need to know the 4 types of friction, but you do need to be aware that friction is a force that opposes motion. Remember, if there's no acceleration, there's not going to be any force. If something is not moving at all, then all the forces are balanced and the net force is zero. For example, say we have some really bumpy ground and we place a box on the bumpy ground. And we subject that box to a force of, say, 4 newtons. So we could expect the box to move this way. If you push the box with a force of 4 newtons and yet it doesn't move, that tells you that the friction force, because of the bumpy ground, must be equal to 4 newtons. Because the two forces are going to balance out. Therefore, the overall net force on the object is 0 newtons. There's not going to be any change. It's not going to move. We can use Newton's second law to express the relationship between force, mass and acceleration mathematically. We say that F equals ma, where F is the force measured in newtons, and 1 newton is 1 kilogram times meter per second squared. The mass is measured in kilograms and acceleration in meters per second squared. Acceleration due to gravity we call g. On Earth, g is measured at 9.8 meters per second squared. So we can say that on Earth, objects are subject to an acceleration of 9.8 meters per second squared. And we can change Newton's second law of motion to read F equals mg. The thing to remember is that your mass on Earth is affected by gravity, and we call this our weight. In language every day, we tend to use the word weight incorrectly. Weight is not mass. Weight is the combination of the effect of acceleration due to gravity on our mass. If you have a quick read through this page, you can see that you push an object and it accelerates. You push harder on the same object and it accelerates more quickly. Yet when you push just as hard on a heavy object, it accelerates more slowly. And that's because of the relationship between force, motion and acceleration. F equals ma. And we can use this to work out some problems. You may be faced with a problem where you're asked to figure out an acceleration, but you're not told the acceleration. You may be told the velocity. So in this case, you can use a formula for acceleration, which is A equals Vf minus Vi over t. For example, if you have an object that is stationary and then travels with a velocity of 20 meters per second over 5 seconds, we can figure out what the acceleration is. It reaches 20 meters per second, starts off as 0, takes 5 seconds, then the acceleration is going to be 4 meters per second squared. If that object weighs, or rather has a mass of 10 kilograms, therefore the force on that object is going to be 10 kilograms times 4 meters per second squared, and the force, which is measured in newtons, is going to be 40 newtons. This is the application of. And lastly, let's look at Newton's third law. Simply put, it says that forces act in pairs, so every action has a reaction. If you push on the desk with your hand, the desk pushes back on you. You can see this because it is there's a mark on your hand. For your quiz, you are going to have to know that g, which is acceleration due to gravity, is 9.8 meters per second squared. Best of luck, everyone. Thanks.
Made with Doodlecast Pro.